go.
Hello!
Hello, Mr. Harry, Mr. Ryan. How are you today?
Good.
Okay, so you know you got the money, yeah? You got the 1p, 5p, 10p, 25p, yeah? Okay? Yeah?
How about no?
No, let's just make it simple. We have 1p coins, 5p coins, 10p coins, 25p coins. Right?
No, 20p coins. There's no 25, there's 20.
Okay, let's just make it 25. No, yeah, you are right.
How come?
It's American. It's not British. Okay, it's American change. Okay, American change. In this problem,
We're not American.
yeah, American denominations. Okay, so that's 1 cent. It's 1 cent, 5
And
cents.
you got
10.
2.
Yes. Okay. Let's
Got 2
just.
pence.
Okay. Let's just make it these 4 numbers: 1, 5, 10,
Okay,
20,
fine.
25. Yeah. And let's say if you want to give people like a money like that, let's say you want to give us 6. What's the minimum coins you need to? That will come up with 6.
Does it have to be exactly?
Yeah, of course. Yeah, 6.
1, 5.
Yeah, 1, 5.
2.
Yeah, 2. Yeah, you are right. And how about 5?
2, yeah?
5. How many?
1.
Okay. How about 3?
3 ones.
Yeah, that's 1, 1, 1, 3. Okay, so you get the meaning. Yeah. If I give you a number like 12, you need to tell me
A
is.
10, 1, 1.
Yeah. Okay. Exactly. Okay. So that's how we make the change. So we want to know the minimum number of coins they make up the money, the target money. Yeah. Does it make sense? Ryan, Eric? Yeah. You understand the problem? Yeah. So how can we do this? How can we do it? Remember, look, this one is a very special case. It means that we can all make it 1, right?
Yeah.
So you'll be less than the number. Okay, you give it a number n. Yeah. Define. How? What's your approach of doing this? Define. Change. Making change. Make
Okay,
change.
so, like, if a number is 12, like Abby said, the smallest coin, which is considered, is 10, and then you have remaining of 2, and
The
and
smaller
then
result
is
be.
1.
Okay, so I understand your approach. So why not find a largest coin that is smaller than the target,
Yeah.
right? And then we use that coin, and then we repeat it. Yeah, subtract that, right?
Yeah.
Yeah, does it make sense? How about okay, so so answer. We want the answer, yeah? Okay? Yeah? Answer. And now look for the coins, yeah, Eric? Look, 4 coins in how many coins there? Let's
4.
we try the biggest one first. 25, 10, 5, 1, right? Yes? Yeah?
Does it have to be these ones?
No, we know these 4 coins, and we want to try the coin. Let's say we want to try the
Does
coin.
it have to be these coins?
Yes, yeah, that's the given. We know it's 4 coins.
So does it have to have 1, 5, 10, 25?
No, yeah, we are trying. So look, we want to find out the largest coin that is smaller than n, right?
But it's
Yeah.
like 1, 5, 10, 25.
Sorry, what? Why is it in reverse order? Do you understand? Because we want to try the largest one, yeah?
Yeah. But it's not always 1, 5, 10, 25.
Then you put it, maybe you want the 20, put it 20 here, or 22 here, yeah? Does it make sense?
Yeah.
Look. So now, so what? So how do we try the largest number that is no more than the target? Any idea how we doing this?
Oh, I think we start at the smallest. Wait, no.
No, we start with the largest one.
Okay. For example, at your 12, and then 25 is bigger, so no. 10, yeah. It's smaller, so that means it's this one, babe.
Okay. So look. So how many coins can we use the C 25? So look, now we are n, right? So this coin will be n divided by 25, right? Does it make sense? If it's more than 25, like 26, you will need 125, right? If less than 25, like 24, this will become 0, right? Yeah? This coin, yeah?
This coin.
Okay, then how many of these answer plus equal this, right? Does it make sense? Yeah?
Why? Okay, yeah.
Does it make sense? This is the number of the coins of the current. Actually, not 25, it's divided by C. Right, Eric?
Mm.
Yeah, Eric, look. Come on, don't walk here and there, okay? 26, okay? N divided by C. This is the number of coins. This is the number, least number of C coins. And then with this answer, we add it to the answer. And then now what should I do? I need to remove it. N minus equals least times what? I just said least times what? N coins. Now we want to make up N coins, but now we know
C.
Times C. And then what should we do if it becomes a 0? If it becomes 0, what should we do?
Oh, we return it.
We're now break the loop, yeah? Break the loop. Yeah, break this loop and then return answer, yeah?
Yeah, but
Yeah? Or you can just directly return answer here. It's the same, yeah? You return answer. But if you return answer, then you don't need to write here, but it would be better if we just return, because we want to return answer when it's 0, right? When it becomes 0, you want to return 0, so we just break. Break. What does break mean?
means break. We stop the loop.
Yeah, we just no matter.
Stop being a national.
Eric. So break loop, it means that we don't want to continue with the loop, right?
Yeah.
We just skip, not skip. We just exit and we return here. Yeah, does it make sense? Yeah.
Yeah.
Okay, I'm going to do this. Okay. What's this? I remove one thing here.
Answer equals.
Answer.
This.
Yeah. Because we need least number of coins. Yeah. Okay. Okay. What's the time complexity of this one? Sorry.
On.
Oh. What?
On.
What?
On. I went.
Oh, what? Look. Can you tell me? Look. Alright.
Yeah.
This n. We know this. So what's the time complexity?
Whoa.
1. Yeah.
Yeah.
Because we only try 4 iterations. We already know it's 4 iterations. It doesn't change. And look, this calculation is this. Eric, this calculation we can. It's the same thing as look. Listen. Yeah, this is the 4 iterations of calculation. So basically, we want to know. We can return it. Look, return and how many nodes of 25? Yeah, how many coins of 25? Yeah, alright, this number of 25 coins plus and you remain 25, right? And then what? And then remain 25. How many 10 are there? Right? You remain 25 divided by 10 plus remain 25 and then remain 10. How many 5 of that? Right? And plus and remain 25. Remain 10, remain 5. How many 1 of that? Divided. No, that doesn't make sense. So these can be turned into one line. Look. Look. This is the number of 25, yeah? Plus remaining of 25 is this bit. Look, this bit is this bit, yeah? This bit. And then we need to divide it by 10 to compute how many 10 coins we need. And then this number keep dividing remaining 10 and how many 5 of them, yeah, and then the next is how many 1 of them. Does it make sense? So these can be changed into these, yeah, but this is more straightforward approach, yeah. We greedily try the largest coin, right? We try the largest coin 25 and then we try 10, we try 5, we try 1. Does it make sense? Yeah. Alright. How about we can use the dynamic programming in this case? Remember, we can use the dynamic programming. Eric?
Using memorization.
Yes. Top down, not top down, bottom up. Okay.
Using the cache.
Maybe we don't. Another solution. Look, you just remember that the time complexity is 01 for that, and our space complexity is also 01, right? Because we're not allocating any more space for that, right? It's 01. This is a very optimal solution. But look, if we use the dp function, right? Look, if the fn, let's say Eric.
Yeah.
If Fn means that the number of minimum coins to represent, to come up with the target n, right? Yeah? And you will be equal what? F, you will be equal to mean of all these, Fn minus I, right? Look, where what? I is 1, 2, 1, 5, 10, 25, right? Does it make sense? Yeah? Yeah? Look, Fn is the number of the coins, minimum coins, to store, to come up with n. And then we know we have 4 choices. So it must be, it must be
I
this.
lost a tooth today.
And plus 1, sorry, plus 1, because we need one more, right? Yeah, does it make sense? Look, F12, right? The number of ways, the minimum coins to come up with 12 is equals to mean of all of these. Yeah, F12 minus 1. No, F12 plus minus 1. F12 minus 5. F12 minus 10. And F12 minus 25. Okay, and then.
That's not really.
Yeah, because this is too small, so yeah, this is too small. Plus 1, right? Does it make sense? So it means this. The previous we can have F2, right? If we know F2, alright? If we know the F2, we know F12 is F2 plus 1, right? Because F12 is 2 plus 10, right? Yeah? And we have 10 coins. Does it make sense, Eric? Does it make sense, this one? Kind of, yeah? Can you tell me why is this? F12 equals F12, F5, F7 plus 1. Can you tell me what's this?
F12 equals.
Yeah.
Isn't that supposed to be this?
Yeah, mean. Okay, so why is mean? Yeah, you're right. This is mean. Why is that?
Cause.
We want to make up 12, right?
Yeah.
And we know that F7, if we
7.
because we have 5, so we know F7, the difference between this is that we have 7 and we just need another 5, right? Yeah, this is one solution, right? And then if we keep iterating this, then we can find the Fn, right? Does it make sense? Yes? Okay, let's try this, okay? Eric, pay attention, you're losing track, you know. Define Fn, what's missing?
Column.
Okay, now look, dp, let's do it dp, yeah? dp equals, at the beginning we set it to a maximum value, yeah? Float or max dot infinity, yeah?
Maths.
Times n plus 1, yeah? Because that we want to access Fn, right? And dp0 will be equal 0, okay? The number of ways to come up with the nothing is nothing, right? Yeah? Now look, for I in range 1, n plus 1, right? This is from 1 to n. For coin in, yeah, you can use this if the set 1, 5, 10, 25, right? Yeah, alright, look. We want to try the coins, and then we want to calculate dpi. Yeah, dpi from 1 to n, right? So the answer will be dp what? The dp what? The answer. Return dp what?
dp.
What? dp what? What are we calculating here?
C.
No, dp what? No, I just said this is. Sorry? Fn is the number of, dpn is the number of the coins needed to make up the target n.
Oh, return.
Return what?
Return that.
dpn, come on. Or dp minus 1, right? Yeah, the last one, right? Minus 1. Look. We are currently targeting the number I, and then we have coin C. If I bigger than or equal than C, right? Yeah? Yeah, we have 25 coins. If 25 is bigger than one of these numbers, if right, and what? dpi minus c is not equals to maximum to the infinity. Yeah, to the inf. And then right, because the dpi minus c, we know we haven't we know how to make it up, right? Does it make sense, Eric? Yeah, because the beginning is infinity. If this dpi if I minus c amount, we don't know how to make it up. We don't know how to come up with I minus c. Then we don't continue. Otherwise, dpi equals mean. Eric, can you tell me what's here? dpi
Wait.
I minus c.
Closing.
Bracket plus 1 dpi, right? Does it make sense? Yeah, we want to compute the dpi minimum dpi value, right? Does it make sense? Is it yeah. dp minus 1, the last value, dpn, right? dpn is the number, okay, let's do this again. dpn is the number of coins, the minimum number of coins, if we want to make up n, money n, yeah, amount of n, right? If we want to come up with if I want to give you amount of n coins, yeah, it will be stored in dpn, right? Alright? dp0 is 0. Why is that? Because like at the beginning it's nothing, right? Yeah? Then the first iteration, I want to compute the dpi from dp1 to dp2 to dp and my n, right? Yeah? This is bottom up.
N plus 1.
Bottom up dynamic programming, right? Yeah? And then for each one, I know we have 4 coins, 1, 5, 10, 25. If current amount I is bigger than the coins, right? If it's bigger than the coins, if it's smaller than the coin, what does it mean? You're giving too much. If I want 10 coins, you give me 25. This doesn't make sense, right? Yeah? Yeah. If I is bigger than C, if the number the money is bigger than the coins, the total amount is bigger than the coins, and if I subtract the coins, yeah, if we already know the number of coins to make up I minus C amount, then dpi is equal to the minimum of this value, dpi minus C plus 1. Can you tell me why we plus 1 here? Because we what? Why we plus 1? What does it mean? Can you explain to me? Why is it plus 1?
Oh, cause like it's not this.
Because we're using which coin are we using here?
We're using
Coin what?
10.
There is no. I mean.
This.
No. Which coin are we using? I mean.
C.
C, of course. Because we use 1 C, then this is the number of coins. Adding 1 more coin C, right? Does it make sense? Yeah. You get it, right? Yeah. We use 1 C coin, and then the amount we subtract C, right? Does it make sense? This is the amount we are making. We want to make an amount I, and we can use 1 coin of C. But then we subtract the amount from I. Then we add 1 coin because we use 1 coin C. Right? Does it make sense? Now it's clear. What's the time complexity? O(n). O(n). Why is O(n)? Why is O(n)? Come on.
Because we're using the I.
Dynamic programming.
Because look, this is n. Yeah, we are iterating n times. But this one, we only iterating 4 times. So it's actually O 4 times n. But we drop the constant. What's the space complexity?
I.
Oh, what? Are we using the space here and here?
Whoa.
Oh, what? dp. What's it? Oh, and come on, it's the dynamic programming bottom up. We always using the space. Look, why is it bottom up? Because we calculating the dp1, dp2, dp3 until we get the dpi, right? Value, yeah? dpn. Right? please. Stop touching my computer, okay?
It's so warm. But
Yeah. What's the wait? This is which one is better? Do you think this solution is better or the previous one?
previous.
Why is that?
Oh, because it's faster.
Why is that? O1 is faster than this ON, right? Yeah, and time complexity is O1 compared to ON here. Space complexity is O1 compared to space complexity ON here, right? Yeah. So the previous one is optimum. You can't get better than that, right? O1 is the fastest. You can't get fastest than O1. Yeah. There's no O0, O minus one, right? O1 is the super fastest, am I right? Yeah. Because you just give me a number, I just do some math, and that's it. But this one I have to iterate linear number of times, right? You give me the number a million, and I need to iterate a million times. That's very slow compared to O1, right? Does it make sense? Yeah, this is bottom up. We can also do it in top down, but not today, okay? We can also do this in top down. Yeah? Yeah? Does it make sense? Alright. How can we do this in top down? Eric, maybe I can write it down, okay? Top down.
With cash.
Yeah, top down, Eric. Let's write this in top down. Come on, Eric. I put a cash here, yeah? Cash. Yeah, put a
No,
cash.
I need to start all
Look.
over again.
If n equals 0, return 0, right? Yeah? Eric,
Return n could be
if n number of coins is 0, we return 0. Else what?
return n.
For, let's do this. We want to get the minimum, right? Answer equals the infinity, mass dot infinity.
Math.
And then for I in you can do this
Point.
curly brace or square bracket, doesn't matter. Okay, 1, 5, 10, 25, right? Look, hold on. Look, I can do this. Like, if n smaller than 0, we return a maximum max dot infinity number. Yeah, because
Can they be?
yeah. Then look, I tell you why we need this. Okay. Then look, answer equals mean. Answer f n minus I. Right? Yeah. And then return.
Answer.
Wait, mean plus 1, right? Remember? Yeah? Yeah? We use the coin. Let's do this C. If we use the coin C, and then we need I. Right? Yes? Does it make sense? Okay? Look, because if it's smaller than 0, that will return infinity plus 1, okay? That's a very special case, yes? Yeah? Alright. Okay. Answer equals infinity. Okay. That's it. What's the time complexity and space complexity for this one? Sorry? Alright.
And
Yeah, it's the same as it's basically the same as the bottom up dynamic programming, yeah? Okay? You want to do some big boxing? Boom, 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 boom.
kickboxing.
Boom, 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 boom. Okay.
Today I lost the teeth.
Oh, well done. Okay.
I pulled it out.
Okay. Oh. Okay. Wait for the tooth fairy. Okay. Bye bye. See you tomorrow. See you. Bye bye.
Bye.
See my Pac-Man.
Did you do that?
Pac-Man.